All right, example 5 gets more into the algebra aspect of these problems in that it doesn't have the right structure to use the power rule. And I know there were some problems in the homework from last night because I forgot to mention that both today and yesterday were the same assignment, so these modifying problems weren't dealt with yesterday. But what I saw some of you do was 6x minus whatever, like you differentiated some of the stuff here, you differentiated that, you kind of multiplied things together. You were trying to develop some techniques to do this because it didn't quite fit what I told you to do. And you tried to do what I said with what you kind of thought, and it just doesn't work, unfortunately. Okay, calculus is a hard class because things that you think seem reasonable usually aren't going to work. So it's kind of an unreasonable thing in that sense. But the nice thing about calculus is there is specific rules and specific things. If something looks exactly like it's supposed to look, then you apply this rule and you get your answer. All right? This doesn't look like it's supposed to look, so what I want to do is I want to transform it using algebra. First thing, as a general rule, anytime you see radicals and you're differentiating, make them into fractional powers. All right? Radicals do not differentiate easily. Fractional powers do. So fractional powers are your best friend when it comes to these. So this right here, square root of x, I'm going to rewrite as x to the half power. And this is 3x squared, which is fine. That's going to be minus 7x to the half power, and then plus 1. So anytime I see a radical, and my job is to differentiate, I'm going to create a fractional power out of that. And again, just a brief algebra refresher here. Okay, whatever root is here, whatever power is in here, the power goes over the root. That's how you make a fractional power. This is an understood square root with an x to the first power, understood also 1 over 2, 1 over 2. All right. Next, this is still a product. So if you look on your yellow sheet, under product rule in that little box, 1d2 plus 2d1, that's what you'd have to do at this point in time if you wanted to differentiate it in its current structure, because currently it's a product. A function of x being multiplied by a function of x, that's how you differentiate a product. Okay? But we have some algebra again that we have the ability to simplify this structure. If I see this structure, an object being multiplied by multiple objects, or even multiple objects times multiple objects, the distributive property allows me to multiply this expression all the way out into something simpler. So f of x, if I do x to the half times 3x squared, I'm going to get 3x to the 5 halves power. Multiplying x as I add the powers, 2 plus 1 half is 5 halves. X to the half times negative 7x to the half makes minus 7x to the first power. 1 half plus 1 half is 1. And then x to the half times 1 is plus x to the half. Applying the distributive property in order to distribute the x to the half throughout the parentheses. Once I do all three products, I end up with a new expression that has no parentheses in it. Renee?
So whenever you're multiplying fractions that are powers, you just basically add them together?
Yeah. Anytime you multiply x's,
Okay.
the same letter, x times x, you're adding the powers. If fractions exist, which they do a lot of times in these problems, the common denominator is required to add the fractions. So 2 is the same as 4 halves. 4 halves and 1 half is 5 halves. 1 half and 1 half is 2 halves, also known as 1. And then, of course, no x here just makes x to the half. Yes. Anytime you're multiplying the same letter together, you're going to add those powers. That's our power rule, or sorry, product rule of exponents that we learned in Algebra 1 and 2. Multiplying x's, you're going to add the powers of the x's. All right, so step 1, distributive property, algebra 1. Step 2, step 1, changing radicals to fraction powers, algebra 1. Late algebra 1, early algebra 2, we did that. And step 2, distributive property, is algebra 1 with the fractional powers, maybe more than algebra 2 level problem. But there's algebra happening here. All right, algebra makes calculus easier. All right, and anytime you have the ability to take an expression that you're looking at and modify it using algebra into a simpler expression. So we went from a product involving radicals, using a product rule, but radicals are involved, into a product involving fractional powers, easier, still using the product rule, into a polynomial structure something x to a power, something x to a power, something x to a power, so we can use the power rule of differentiation. That's the key to these problems. Keep modifying until you get a single number times a single x to a single power. Once you get that structure, you're ready to go. So 3x to the 5 halves. Now I'm doing my calculus. Now I'm applying one of my differentiation rules, so I'm going to put that f prime on it. Once I start doing calculus, the prime goes on my f. 5 halves times 3 is 15 halves. The rule says then I subtract 1 from the power of 5 halves minus 1 is equal to 3 halves. Minus 7x to the first. 1 times negative 7 is negative 7. I get x to the 0, better known as 1. And then plus, and 1 half times 1 is 1 half, x, and then 1 half minus 1 is negative half. So again, once I create this basic polynomial type structure, number times x to a power for each term, I differentiate each term individually with the power rule. I get my nice derivative without too much difficulty. And that's the answer.